Today I'm going to talk about how is determined the influence of fiber types on some properties of cell-compact mortar. Therefore, the main objective of this investigation is to evaluate the influence of the type of cement mortar in fresh mortar, hardened and mortared using mineral mixtures as a partial replacement of 8% by weight of cement. In addition to that, study the effect of fiber types used with the favored volume fraction of 1.5% on the properties of cell-compacted mortar. The materials used in the research was the Portland cement, potable water, fine aggregate, hard-rain superplasticizer, water using additive, silica fume that was used in the mixture as a mineral additive to replace the 8% by weight of the cement, different steel fibers in shape that in this study two forms of steel fibers were used, which are not the same in form and aspect ratio. The first type was 30 mm long with an aspect ratio of 60, whereas straight steel fiber was the second type with a length of 15 mm and an aspect ratio of 75. Many trail mixtures were prepared to find a suitable self-compacting reinforced mortar that has the right properties in the cool state. The performance of self-compacted hybrid fiber reinforcement cement mortar in a fresh and hardened state and the role of some of its components in it were investigated through the preparation of 5 mixtures. Tests that was used in the research: determination of the flow of the control mixture, test for first self-compacting mortar, apparent density, compressive strength, modulus of rupture. The results of the investigation show us that the results of the mini-draw flow test that gave the proper filling and flow capacity for the self-compacted mortar are shown in the table number 9. It is obvious that it is very important to use superplasticizer in compacted automortars to achieve an homogeneous mixture with a low water binder ratio. Moreover, the addition of 8% of silica fume as a partial substitute for cement mortars leads to an increase in water demand and decrease in working capacity, and a recurrent increase of those superplasticizer for the same low ratio water binder. Another results indicate that the use of superplasticizer cause an increased compressive strength as the decrease of ratio water binder to 0.28, which cause a high reduction of porosity of the hardened seams and therefore an improvement in compressive strength. On the other hand, the substitution of 8% of weight of the cement by the silica fume induced a new increase of the resistance of the mortar to overcome, and the inclusion of the microsteel fiber in the mixture improved its compressive strength due to the effect of a steel fiber on the groove bridge of micro cracks and consequently leads to a higher strength of the compound. It is clear that the specimen made that the hybrid fibers show a greater strength compared to specimens of microfibers. So we can conclude that it is possible to produce self-compacted reinforced mortar using the mixing ratio of 950 of cement, 950 of fine sand, 76 densified silica fume, and all of the values are given in kilogram per cubic meter. In addition to that, the ratio of water and cement of 0.28, superplasticizer, and 1.5% volume fraction of steel or hybrid fiber microfibers. The drop flow of the mixtures produced tends to vary between 240 and 260 millimeters for the fresh properties of the self-compacted reinforced mortar. The use of superplasticizer to control the mixture caused that the water and cement ratio to be reduced from 0.5 to 0.28, and also provides an homogeneity, fluidity, and resistance to mortar segregation. The self-compacted mortar contains densified silica fume shows a significant increase in a compressive strength and modulus of rupture compared to the silica fume free mortar. The percentage increase in approximately 24.1% and 47.3% respectively. And also the incorporation of 1.5 volumetric fraction of steel or hybrid microfibers into self-compositive mixtures with densified silica fume in comparison with the corresponding mixtures without fibers caused an increase in compressive strength to about 24.4% and 35.3% respectively, and in the brake module to about 159.5% and 192% respectively.